Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 26, determined by direct integration the moments of inertia of the trapezoidal area about the x and y axis. Find the polar moment of inertia about point O. So here is the given figure, which is a trapezoid. For our solution, let's have a horizontal strip so that we only have one strip, one integral, and the thickness is dy as shown, and the distance of the strip from the x-axis is y. So differential Ix is distance square y square times differential area, which is x dy. And this point, this corner here, will have coordinates of x a, y is h, and this one is x is b and y is 0. And we have a point here which is x and y coordinate, then here b 0. So differential Ix is y square times differential area, which is x dy. Then let's derive formula for x for this side here, which is a straight line. So y minus 0 slope over x minus b equals h minus 0 over a minus b. So therefore x minus b is a minus b times y all over h. A minus b quantity times y over h. So therefore x is b plus quantity a minus b times y over h. We substitute it here. So the Ix therefore is integral from 0 to h of y squared quantity b plus a minus b y over h dy. So if we imagine that this is u, or we can evaluate the integral because this is constant, we have by squared plus a minus b over h constant times y cubed. So the integral is by cubed over 3 plus a minus b over h times y to the fourth over 4. Then limits from 0 to h. So substituting the upper limit, we have b h cubed over 3. Then we have a h to the fourth over h over 4. So that's a h cubed over 4. Then minus b h cubed over 4. So that means we have ah cubed over 4, then 1/3 bh cubed minus 1/4 bh cubed is 1/12 bh cubed. So Ix is quantity bh cubed over 3 plus a minus b over h to the fourth over 4. Then when we substitute the lower limit for y, everything will be 0. So that's why I'm not showing it here. So simplifying again, we have ah cubed over 4, then 1/3 bh cubed minus 1/4 bh cubed is bh cubed over 12. So Ix is ah cubed over 4 plus bh cubed over 12. Factoring out h square over 12 or h cubed over 12, then Ix is quantity h cubed over 12 times 3a plus b. So that's Ix. Then Iy, we have a strip with respect to the base dy. So differential Iy is 1/3 x cubed dy. Since we have already derived x, which is this, so Iy is 1/3 integral of from 0 to h of quantity b plus a minus b over hy cubed dy. So if we let this entire expression inside the brackets as u, Then the differential is a minus b over h dy. So there's no a minus b over h dy, which is a constant. If we multiply this to make it du, then that means the reciprocal should be written here, which is h over a minus b. So Iy is 1 h over 3 a minus b integral 0 to h of quantity b plus a minus b over hy times a minus b over h dy. So again, the reciprocal a minus b over h is h over a minus b. We have already 3 here from 1/3. And this is in the form integral of u cubed du. So by power formula, that is just u to the fourth over 4. So Iy is h over 3 quantity a minus b quantity b plus a minus b over hy quantity to the fourth over 4 from 0 to h. So if we substitute the upper limit, this is h over h, which is 1. So we'll have b minus b, so b will vanish. Then we have 12 here, 3 times 4. So what remains is a. H over h is 1, so a to the fourth. When y is 0, lower limit, so this will be 0, then we have b to the fourth over 4. So Iy is equal to h over 12 quantity a minus b quantity a to the fourth minus b to the fourth. Again, when we substitute the upper limit, h over h is 1, then we have b plus a minus b. So what remains is a, so a to the fourth, which is this. When we have lower limit 0, so the whole of this is 0, then that's why we have minus b to the fourth. So Iy therefore is factoring a to the fourth minus b to the fourth, h over 12 a minus b times quantity a square minus b square times a square plus b square, difference of two squares. And take note that this is a minus b. If we factor out this further, a minus b, a plus b, so we can cancel a minus b. So we have a plus b times a square plus b square for the simplification of this right side here. H over 12, Iy is h over 12, quantity a plus b times a square plus b square. So finally, Iy is h over 12 times quantity a cube plus a square b plus ab square plus b cube. Again, Iy is h over 12 quantity a cube plus a square b plus ab square plus b cube. That's the expansion. Then for the polar moment of inertia, about point O, it is just Ix plus Iy. So Io is Ix plus Iy, and it is h cubed over 12 quantity 3a plus b plus h over 12 quantity a cubed plus a square b plus ab square plus b cube. So factoring out the common factor, which is h over 12, so Io is h over 12 quantity h squared times 3a plus b plus h cubed plus a square b plus ab square plus b cube. So that's it. That's the polar moment of inertia. Level 27, determine the moment of inertia of the elliptical area about the x and y axis and find the polar radius of gyration about the origin O of the coordinates. So here is the figure, and remember the equation of an ellipse with center at the origin is x squared over a squared plus y squared over b squared equals 1. So let's select a strip which is vertical, and the height of the strip is y, the thickness is dx, distance of the strip from the y-axis is x. Take note that we just consider one region of the ellipse in one quadrant, and there are 4 identical quarter ellipses. Therefore, we multiply the differential moment of inertia by 4. So differential Ix equals 4 times quantity 1/3 of y cubed dx. That's the moment of inertia of an elemental rectangular strip with respect to the base. moment of inertia. So y square over b square equals 1 minus x square over a square from the equation of the ellipse here. So if we cross multiply and simplify, we have a square minus x square over a square. So y square is b square over a square, quantity a square minus x square. Then extracting the square root, so plus minus, but we select plus, so y is b over a, then square root of a square minus x square, or b over a times a square minus x squared to the quantity to the 1/2. Therefore, y cube here is b cube over a cube, then quantity a squared minus x squared to the 3/2. So ix is 4/3, b cube over a cube, integral from 0 to a of a squared minus x squared raised to 3/2 dx. The variable of integration is x, therefore the limits would be from 0 to a. Then from our experience with calculus, when the integrand involves constant square minus variable square, we put the variable equal to a sine theta. So that means the differential of x is a cosine theta d theta. And we form a triangle defining sine theta here. Right triangle, sine theta is x opposite over hypotenuse a. Then by Pythagoras theorem, this is square root of hypotenuse square minus x square, and it is a hypotenuse cosine of theta. So this one therefore is a cosine theta cube, because this is square root. Now, when we change limits here, when x is 0, 0 over a is 0, arc sine of 0 is 0. So the lower limit is still 0. But when x is a, upper limit, a over a is 1, and inverse sine of 1 is pi over 2. So we change limits of 0 to pi over 2. Then we have ix equals 4b cubed over 3a cubed, integral from 0 to pi over 2 of quantity a cosine theta cubed, then dx a cosine theta d theta. So this is, when simplified, a to the 4th divided by a cubed. So a cube can be cancelled here. This becomes 4ab cubed over 3. Then integral from 0 to pi over 2 of cosine to the 4th d theta. We can apply Wallay formula here. Wallay formula. Definite integral. So sine does not exist. The rule is we change it by 1. Then cosine to the 4th. So the exponent or the power of cosine is 4. So that means we begin with 4 minus 1, which is 3, decreased by 2, so 3 times 1, then we stop. So 1 for sine does not exist, then 3 times 1. Alpha is pi over 2 because 0, power of sine, and 4, cosine are all even, so the alpha is pi over 2. All over sum of powers, which is 4, decreased by 2, so 4 times 2, we stop at 2. So the denominator is 4 times 2. So ix is 4ab cubed over 3, then 1, 3 times 1, 4 times 2, pi over 2. So again, this is for the sine, but the rule is we replace it by 1. This is 4 power of cosine, 4 minus 1, so 3, decreased by 2, so the next is 1. We stop at 1 because the ruling is we stop at 1 or 2. Then alpha is pi over 2 because 0 exponent of sine and 4 exponent of cosine are both even. Then this is the sum of powers. 0 plus 4 is 4, decreased by 2, so the next is 2. We stop at 2. So we can cancel 4, cancel 3. Therefore, ix is pi ab cubed over 4. Just like a circle, pi rr cubed over 4, or pi r4 over 4. So that's it. And in this case, because the ellipse have major and minor, the one that is cube is perpendicular to the x-axis, which is b. So that's why we have ab cube. We expect also that iy is pi over 4 a cube b. So let's check that. So differential iy is 4 times x squared times differential area y dx. So that's the moment of inertia, differential moment of inertia of this element here. Distance square times differential area y dx, then multiply by 4 because we have 4 identical quarter ellipses. Then we substitute the value of y. Variable of integration is still x. So differential y is 4, quantity x squared, then y is b over a square root of a squared minus x squared dx. Limits would still be 0 to a originally. Then iy is 4b over a, integral of from 0 to a of x squared square root of a squared minus x squared dx. So we change limits again to 0 to pi over 2. X is a sine theta, and this radical here is a cosine theta. Dx is also a cosine theta d theta. So iy is 4b over a, integral 0 to pi over 2 of quantity a sine theta square, then a cosine theta times a cosine theta d theta. Simplifying, we have a to the 4th over a, so iy is 4a cube b, or b a cube, integral 0 to pi over 2 of sine squared theta cosine squared theta d theta. So again, we can apply Wallay formula. So for b a cube, for sine 2 minus 1 is 1, stop. Cosine 2 minus 1 is also 1, stop. Alpha is pi over 2 because both 2 and 2 are even, divided by sum of powers 4 times 2. So we also stop. So iy is 4b a cube over times quantity 1 times 1 times pi over 2 over 4 times 2. So I already explained that from Wallay formula, and you also have experience from integral calculus. So 4 over 4 is 1, so that's why we have pi a cube b over 4 as expected. Then the radius of gyration about the origin, ko is square root of jo over area, and jo is simply ix plus iy, or io over area, square root of io over area. Io is ix plus iy. So pi ab cube over 4 plus pi a cube b over 4. Factor out pi ab over 4, then we have a square plus pi ab over 4, quantity a square plus b square for io. Then area of ellipse is pi ab, just like circle pi rr. So ko is square root of pi ab over 4, quantity a square plus b square, all over pi ab. So cancel out pi ab, then we have square root of a square plus b square over 4, which simplifies to square root of quantity a square plus b square over 2. So that's the radius, polar radius of gyration about the origin. Level 28 show that the moments of inertia of the square area about the x and x prime axis are the same. So here is the square oriented in this manner. So for ix, we just consider a rectangle above the x-axis, and with respect to the base, we already know that the moment of inertia of rectangle with respect to the base is base height cube over 3. Then we multiply it by 2 for the lower part. So solution, ix is 2 times I of rectangle, so 2 times bh cube over 3, where the base is this one parallel to the x-axis, which is a, and the height is a over 2. So ix is 2 over 3 quantity a over 2 cube. So simplifying, this would be a to the 4th over 12. So ix is a to the 4th over 12. Then for ix prime, So we just imagine that it is moment of inertia. This is the base of a triangle, right triangle, with respect to the base. And from our experience, it is base height cube over 12, then multiply it by 2 for this part here, where the height, this one, is because this length and that length are equal. So this is A, this angle is 45, so A sine of 45 degrees is A square root of 2 over 2. This is A square root of 2 over 2, also A cosine of 45, which is equal to this A square root of 2 over 2. Then since this length is also equal to this length times 2, so it is A square root of 2. So again, the moment of inertia with respect to x prime axis is 2 times the moment of inertia of this triangle, where the base is A square root of 2 and the height is A square root of 2 over 2. And the moment of inertia of a triangle with respect to the base, with our experience, is base height cube over 12. So Ix prime is 2 times I of triangle, 2 times BH cube over 12, where our B here is this one, A square root of 2, and the height is A square root of 2 over 2. Substituting, Ix prime is 1/6 of base A square root of 2, height A square root of 2 over 2 cube. So if we simplify this, this is A to the fourth, square root of 2 to the fourth is 4, divide by 2, so 2, 1 half, rather, 4 over 8, because this is over 2 to 2 cube, so 8, 4 over 2 is 1 half. 1 half times 1/6 is 1/12, A to the fourth. So it's the same as this. So we have shown that Ix is equal to Ix prime. So that's it.